Okay, so in this video, we're going to talk about dilations, not about the origin. When that happens, these are the 3 steps we need to follow. Okay, so I will go over each step as we're doing the problem. So consider the following graph. Under dilation of scale factor 2/3 centered at -8,2, segment KP becomes segment K prime P prime. Determine the coordinates of segment K prime P prime and sketch segment K prime P prime on the graph. Okay, so we'll do one thing at a time. Let's look at the key words that we see here. We see scale factor and where it's centered. So we need the scale factor, which is 2/3, and it's centered. Notice not centered at the origin or it says about the origin. It's at a point. That's how you know, okay, I have to do these 3 steps because it's not at the origin. So where is my center of dilation? It's at -8,2. Same location where K is, okay? That's where we're going to dilate it. Okay, so let's follow these steps. So we're going to just work with K first. Okay, so K is located at -8,2, same location. Okay, so for step 1, we're going to subtract the center of dilation from a point. So basically what you're going to be doing is changing both signs of the center of dilation. So this is not at the origin, the center of dilation. But if I wanted to get there, I have to move 8 right and then down 2. 8 right, down 2. Notice it's the opposite signs. So instead of subtracting -8 minus -8, just change the sign of both. Okay, so for step 1, we're going to have the -8 and 2. And we're just going to go ahead and do the opposite signs. So it'll be +8 minus 2. So when you add this up, you get 0, 0. Okay, that's step 1. So we moved the center of dilation to the origin now by doing that. Step 2, we're going to multiply by the scale factor. My scale factor is 2/3, so I'm going to take the x value multiplied by 2/3, and same thing for the y. So that is step 2. So step 2, we had 0, 0. Now we're going to go ahead, we have to multiply by the scale factor. So it's 2/3 times 0. Kind of don't have enough space. Let me make this bigger. So the scale factor is 2/3 times 0, the x value, and we're going to do the scale factor 2/3 times the y value, 0. Now you don't have to waste time putting 0 over 1 because 0 times anything is just 0. So in this case, it will be 0, 0. All right, and the final step, we're going to add the center of dilation. So remember, we moved this point, right 8 down 2, and we did the scale factor. That's what we just did. But let's move it back. So I have to go back to the same direction. I have to go left 8, up 2. And the reason I'm doing that order, left 8, then up 2, because always your x values first, then your y. So the final step, step 3, in order to find K prime, we're going to take 0, 0, and it says add the center of dilation. So the center of dilation is -8, 2. Just go ahead and put it back. So you're going to get for K prime, it's going to be located at -8, 2. Now if I go on my graph, -8, 2, that's where K is. That's where the center of dilation is. In this case, K prime is also here. Okay. Now we're going to go ahead and go find P prime. P is located at 1, -7. We're going to follow again these 3 steps, but now with this ordered pair. So step 1, you're going to change the sign of the center of dilation. So 1, -7. The center of dilation was -8, 2. I changed the sign of both, so it's be a +8 minus 2. So for step 1, it results to 9, -9 when you add across. Now let's go ahead and do step 2. Multiply by the scale factor. I'm going to take 2/3 and multiply the x and then the y. So step 2 is going to be right here. So I'm going to take 2/3, the scale factor, multiplied by the x value, and then take 2/3 and multiply by the y value, -9. Sometimes I will put parentheses on the -9, other times I won't, but I could just leave it like that. So in this case, I have to multiply it. I have a fraction. This is not a fraction, so we could put any number over 1. So it's going to be like that. That way now we can multiply the numerator, which will be 18, and then the denominator, which is 3. That'll give you -18, 3. Now, we could reduce this. This becomes 18 over 3 is 6, and that becomes -6. So right now we just did step 2. The final step is we're going to put it back. So we're going to add the center of dilation back to it. So we had 6, -6. The center, add the center of dilation, it was at -8.2. Just go ahead and add that back in there. Okay, so that means P prime will be at -2, -4. That's where P prime is located. So I'm going to go back to my graph, -2, -4. That's where P prime is. Now this, it's hard to see, but the K prime, P prime is on top of the segment KP. The reason is, and on the notes it says that, if if your center of dilation, which was at -8.2, if it's located on your segment, that means the image will be also on the same segment. So that's what happens right here. If the center of dilation was not on the segment, it was like somewhere another point, then you'll see parallel lines. But in this case, it was on the segment, so that means your image will be right on top of it on the same segment.